This is just a short video on GCSE Physics forces. Just to recap some of the concepts basically. A force is a push or a pull. It can cause a body at rest to move, or if a body is already moving, it can change its speed or direction of motion. A force can also change a body's shape or size. We can show the forces acting on an object using a force diagram. In a force diagram, each force is shown as a force arrow. An arrow shows the size of the force, the longer the arrow, the bigger the force, and the direction in which the force acts. So you might have an object, in this instance it's a crate, and you might have a rope, but what the examiner is looking for is for you to be able to draw what's called a free body force diagram. All that means is you draw something that looks similar shape to the object you're talking about, and then you put arrows on to represent the forces, and you label them. And you do this with a ruler and a pencil, and you put the arrow on in the direction that the force is acting. So the tension is being caused by the rope, but we don't care about the rope in the free body force diagram, we just care about the force being caused by the rope, and that's tension. And then the weight is acting downwards, the weight of the crate. Newton's laws. First, a body's motion will remain constant unless acted upon by an unbalanced external force. Newton's second law can be simplified to F equals m times A and multiplied by A, where F is the resultant force acting on the object. Newton's third law, when a force acts on an object, another force of the same type, equal in size but opposite in magnitude, acts on another object. The force also needs to be of the same type as well. So if it's a gravitational force, if the first force is a gravitational force, for example, then the second force in the opposite direction also needs to be a gravitational force. Sometimes this is remembered: for every action there is an equal and opposite reaction. That's good enough for GCSE in most syllabuses. E.g., helicopter blades push air downwards and air pushes blades upwards. Lift. A stationary object remains stationary if the sum of the forces acting upon it, the resultant force, is zero. A moving object with a zero resultant force keeps moving at the same speed and in the same direction. If the resultant force acting on an object is not zero, then two things can happen. If it's previously stationary, then it can be given to accelerate in the same direction as the force, or if it was previously moving before the resultant force acted, then that object can speed up, slow down, or it can change direction, importantly. So something moving in a circle, for example, even if it's moving at the same speed, it's constantly changing direction, and therefore it's actually accelerating. The magnitude of the acceleration depends on the force applied to an object and to the object's mass. Here's just a few examples. Here's an object, square object, upwards force of 5 newtons, downwards force of 7 newtons, so the resultant is 7 minus 5, 2 newtons down. Here we've got a 15 newtons to the left, 10 newtons to the right, so the resultant force is 15 minus 10, which is 5 newtons to the left. And final simple example is that we have an upwards force of 210 newtons, a downwards force of 160 newtons, so the resultant force is 210 minus 160, 50 newtons upwards.